Hello, I'm Amara Rasgus with Consulting Specifying Engineer, and I'm here today to pick the brain of Wissam Balshe about the electrical and power industry. Wissam Balshe is Director, Energy Management Solutions with Cummins Incorporated. He's been involved with the power industry since 2002, and he joined Cummins in 2007. He led the Sales Application Engineering Group and then led the Strategic and New Growth Business Development efforts for the Power Solutions business. His focus is on distributed generation, microgrid applications, and integrated system solutions. Wissam currently leads the Global Energy Management Solutions business for the power generation segment. It's great to have you here today, Wissam.
Thank you, Amara. Happy to do this interview, and thank you for interviewing me.
Yeah. So let's talk about probably one of the top of mind questions. What smart devices are engineers requesting for their clients, and how are you meeting these needs?
Yeah, that's a great question. So consulting and specifying engineers are very busy, as we all know, designing and handling many projects. So they must think about the entire power flow, from the utility and standby backup power upstream, all the way down to the outlets. They need to evaluate the short circuits, protection, selective coordination, and most importantly, how to easily integrate all these equipment. So we're seeing more and more requests for fully integrated and intelligent or smart controls to be able to meet the many different and stringent code requirements. I believe that Cummins Power Generation leads the market in this space because we've been integrating all gensets, paralleling functions, and protection into a single robust controller since the early 2000s. So we've been doing this for a long time. We've introduced the power command controls for generator set synchronizing and protection, like I said, more than 20 years ago, and we led the industry in that space. Last year, we introduced the best-in-class automatic transfer switch, which is what we call the X-Series transfer switch. What I really like about the X-Series transfer switch is it has a fully integrated control in it. So it has the smart control integrated in or on the ATS, which is responsible for sensing, protection, communications, load management, high accuracy, power quality metering, which is very important to get real-time data. The other important feature about the X-Series is the most robust mechanism. It's best in class in the industry. So Cummins designed a high endurance mechanism with a blow-on technology, which is a patented technology, which allows the ATS to survive in extreme fault currents. We're talking really high levels. So it would survive in extreme fault current conditions and provide the highest withstand and closing rating in the industry. So that withstand and closing rating, in short, WCR, is very important for selective coordination and is also very important as we start adding more distributed energy sources on the bus or the system. So for the CSEs out there, the major challenge during the design phase ranges from unknown switchgear or switchboard from the OEMs, which means they don't know what breaker they're gonna get. The unknown breaker selection makes it also difficult to know what available fault current they have to deal with, though this makes the whole selective coordination job very, very difficult. So selective coordination, by the way, is required by code, right, for emergency and life safety loads. This is why we keep mentioning selective coordination. So to help this challenge or this problem, resolve this problem, our high time based and short time WCR and the X-Series transfer switch will give the consultants and specifying engineers the freedom to select any generic UL listed overcurrent protection device to help protect their critical loads on the transfer switch. We are breaker agnostic. We don't try to sell anyone on specific breakers for our ATSs like many other breaker-owned transfer switch companies do, right? So that's one of the key advantages that we have, and this is what we're really focusing on, right? Giving you that flexibility is going to ease the job of selective coordination. So simplifying the selective coordination is really our main goal. With this new transfer switch, the entire journey of power from upstream to downstream will be easier because we're going to provide value to all partners or parties involved in this whole value chain. Not only the consulting and specifying engineers, but also the electrical contractors and those responsible for the installation and commissioning of the system. We do so by providing ease of wiring, ease of integration. We give enough or an ample inside space for the transfer switch to work with inside the cabinet, and various access options for technicians to work with and for installers to work with. For the facility managers and the operators, the high WCR ratings and capability means that our transfer switch will survive, again, like I said, in extreme fault conditions, preventing costly repairs or inconvenient downtime after a fault. So the new transfer switch, the X series, our power command controls, our integrated switch gear, we build our own switch gear and package our own switch gear, and our cloud-based remote monitoring devices is how we meet our clients' smart controls and systems needs in this space.
Okay, yeah, sounds very all-encompassing.
It is. I mean, the system integration is really important in this space. And one of the things that I think we do very well is integrating different sources of energy. And we've been doing it since the 1960s, right? For a long, long time.
Okay. So let's switch gears here a little bit, Wissam. So looking at electrical engineers, those involved in specifying electrical systems, what should they know about electrical and power systems, or what should they consider when designing or retrofitting control systems in these buildings?
The first thing they need to start with is understanding what codes and standards they have to comply with, right? UL, NFPA, CSA, IBC, OSHPA, there are a lot of different codes and standards. So for example, transfer switches are applied in many different applications that are, they typically fall under one of categories by code. So those four categories, according to the National Electric Code or NFPA 70, are emergency systems, legally required systems, optional standby systems, and critical operations and power systems. So you really need to understand which category your load is under and design the system accordingly. That will play a big role in determining what kind of transfer switch or switch gear or control you require. You need to pay special attention to NFPA 70 Article 517, NFPA 99 for healthcare facilities, OSHPAD, the Office of Statewide Health Planning and Development, and for California projects, seismic requirements and IBC compliance. If you're retrofitting a system, then you need to know how much real estate you have to work with, right? How much space do you have available for the new equipment? So we kept all that in mind when we introduced our new transfer switches. We've integrated the controls in our system to save a lot of space, since a lot of the intelligence is integrated on the generator set and transfer switch controls. You don't need space for another PLC or a system level control. If the genset is already on site, then you need to know what type of controls that you have on these gensets, how to handle harmonic distortion based on the alternator windings in the genset, right? So the alternator winding pitch is important, especially when you have a lot of non-linear loads, right? A lot of like power electronics driven loads, pulse width modulated loads, and things of that nature. So you should understand all of that ahead of time to avoid project delays and going over budget. If you need to change the controls or the transfer switch or change the alternator on the genset. In many cases, we have to change the actual alternator on the genset. So the most important thing for the consulting and specifying engineers to provide performance-based specifications, work early on in the design stage with the manufacturer's applications engineers. That's very, very important. Every large manufacturer has a team of application engineers that should be able to work with the consulting and specifying engineer to help design these systems and prevent mistakes, and make sure that you optimize the system solution and get the most cost-effective solution that meet the code requirements and your customer needs.
Okay, that's great. And so my next question, you've already dived into this just a little bit, but let's talk about challenges. What are some of the challenges associated with emerging technologies, and how can consultants or electrical engineers stay in step with all these new technologies?
That's a great question, because we're dealing with a lot of that now, right? With destination net zero for a lot of companies. Everyone's asking for low carbon or no carbon technologies and renewable energy. So understanding the capabilities and limitations of these new technologies is key, right? You need to know how you're going to integrate these new distributed energy resources, and it gets even messier when you have to integrate old distributed energy resources with new distributed energy resources. So integrating these DERs and ensuring that they can communicate together, and with the building management system, the cloud for remote monitoring, to participate in demand response and demand side management applications, all that is very important. So the key here is figuring out how you're going to integrate everything. We're seeing more and more renewables being part of these power systems, right? PV on the roof, batteries and energy storage. Hydrogen is a new big one, right? Hydrogen fuel cells, it's a new technology starting to enter the power gen space. And all these new renewables, they're all connected to the system through inverter-based technologies, right? They all have inverters, not like traditional gensets. So the transient characteristics of these power sources vary. They're very different than the transient characteristics of the traditional rotating machines like generator sets. This is why the consulting and specifying engineers should work with a system integrator and a developer that will take the full responsibility for the integration of the entire system, not only the component OEMs, right, and manufacturers. Everyone wants to sell you the component. The differentiation doesn't come only from the components, is how easy it is to integrate all these components together. So keep system integration in mind when you're working with these new technologies.
Fascinating, Wissam. Thank you very much.
Thank you, Maren. Thank you for interviewing me. And I want to encourage all the consulting and specifying engineers to continue attending the power seminars by the amazing CSE webcast. And, I know you guys offer it monthly. Cummins also offers in-person and online power seminars that are accredited by the International Accrediting Agency for Continuing Education. So hope to see you guys there.
Fantastic. Thank you so much. We appreciate you joining us today. Goodbye.
Thank you. Have a great day.